Hello everyone, I am Taufeeq Alam from Gopal Narayan Singh University. Today I will be explaining Kirchhoff's current law and Kirchhoff's voltage law, which are fundamental laws used in electrical circuit analysis. So why these laws matter? These laws form the basis of electrical circuit analysis. They are used in nodal and mesh techniques and are widely applied in electronics power system and PCB design. So let us understand about its basic terms. Before understanding this law, we must know some basic terms. A node is a point where two or more elements connect. A branch is a path between two nodes. A loop is any closed path in a circuit. So let us understand through this figure. Here we can see the node at point B, and from point A to B and again to the voltage VA, it is forming loop. Now let us go to the next slide. Next slide tells about the Kirchhoff's current law. Kirchhoff's current law states that the total current entering a node is equal to the total current leaving the node. The law is based on the conservation of energy. We can see through the diagram the current entering I1 I2 is almost equal to current leaving through I3 and I4. Now the next slide tells us about the KCL equation. We can see through the previous slide through diagram. It is same. It is the total current going through a node is equal to the total current coming out from it. So mathematically, KCL can be written as summation of incoming current equals summation of outgoing current, or simply the algebraic sum of currents at node is 0. So let us understand through example. Here we can see that 5 ampere currents enters the node and 2 ampere leaves. So the remaining current must be 3 ampere leaving the node. This satisfies Kirchhoff's current law. Now let us move towards the concept of KVL. Kirchhoff's voltage law states that the algebraic sum of all voltage around a closed loop is 0. This law based on the conservation of energy. KVL equation. According to the KVL, the source voltage is equal to the sum of all voltage drops in the loop. Now let us understand it through the help of example. In this loop, the battery provides 12 volts. Actually, this we can see through the figure there are unknown variables are given, and in the problem we assume that in this loop the battery provides 12 volts, one resistor drops 7 volts, so the remaining voltage drop must be 5 volt. This satisfies Kirchhoff's voltage law. Now understand the application of KCL and KVL. KCL and KVL are widely used in electronic design, power distribution, circuit debugging, and simulation software like SPICE. KCL can be compared to water flowing through a junction. KVL is like completing a round trip. The total energy change becomes 0. Now let us go toward the summary. To summarize, KCL deals with current at node and KVL deals with the voltage in a loop. Both laws are essential for analyzing circuit. Thank you everyone for watching.